Welcome back to our online class. In the previous video, we proved or derived some formulas that we can use in calculations on electromagnetic induction and electromagnetism. So today we'll be taking some few problems here. And the first one here is that a conductor of length 15 centimeter is moved at 750 millimeter per second at right angles to a uniform flux density of 1.2 Tesla. We are to determine the EMF induced in the conductor. Now, we are going to bring out our parameters. The length of the conductor, L, length, let's say solution. The length of conductor L is equal to what? 15 centimeter. If I change that to meter, it's equivalent to what? 15 times 10 raised to the power minus 2 meters, right? Very good. Now, we said it's moved at 750 millimeter per second. So that's the velocity. V is 750 millimeter per second. Do you know I have to change this to meter per second for the uniformity of the dimensions or of the unit. So that will be 750 multiplied by 10 to the power minus 3 meter per second. And I'm to determine the EMF. Okay, we are given that at right angles to uniform flux density of 1.2 Tesla. So flux density, and our flux density B is what? 1.2 Tesla. So we have to find what? EMF. To find EMF induced. EMF unknown. Remember, we derived that E can be equal to what? BLV. And if it were to be at an angle, it would have been BLV sine angle, that's sine theta. So we just input our values here. So we have the length of our Tesla here is 1.2. That's our flux density, flux density 1.2 Tesla multiplied by the length of the conductor is 15 multiplied by 10 to the power minus 2, and the velocity is what? 750 multiplied by 10 to the power minus 3. And our answer is going to be, if I press that on my calculator, I'm going to have 0.135 volts. So that is the answer to that. Now, remember, if it's at an angle, if you have an angle in the question, just put BLV sine theta. Then sine of the angle multiplied by what you have here, you are good. Now, the second question here, we have find the EMF induced in a coil of 200 turns when there is a change of flux of 30 milliweber linking with it in 40 milliseconds. This is milliseconds, 40 milliseconds. Now let us bring out our parameters. We have to find the EMF induced. E is unknown. In a coil of 200 turns, the number of turns N is 200. When there's a change of flux of what? 30 milliweber. That is phi equals what? 30 milliweber. That is 30 times 10 to the power minus 3 what? Weber. Now, the solution to this, if you have this situation, you are also given what? The time. That is your T or dt. Let's put the theta here because change of flux, so that we can have the T here to be what? 40, since it's milli times 10 to the power minus 3 seconds. Recall that we generated a formula that induced EMF E is equal to negative N d phi dt. So if I put my values, I'm going to have negative 200 multiplied by what? This, the phi. Actually, it's supposed to just be phi, you know. So that's 30 times 10 raised by minus 3. 30 times 10 raised by minus 3. All divided by what? The t, that is time, which is what? 40 times 10 raised by minus 3. And if you do that, your answer is going to be, if I press that on my calculator, the induced EMF is negative 150 volts. That is the answer to that. Now, don't forget again that we proved that N the phi dt is also equal to what? L the high dt. In case you have the type of question. Now, the next question here. We are given that the energy stored in the magnetic field of an inductor is 80 joules when the current flowing in the conductor is 2 ampere. We are to calculate the inductance of the coil. Now, if I bring out the parameters, the energy is a solution here. This time around, let's put solution. We will not be putting solution. Now, we have that the energy is represented with what? W. We represent our energy with W. Energy, let's put energy. W is what? 80 joules. 80 joules. And the current I equals to what? The current I equals to ampere. We have to calculate the inductance. Don't forget, what's our inductance? Our inductance is L. Inductance is unknown. Now, you recall that we said that the energy is energy W equals 1 over 2 Li squared. Right? So, if I'm to find L, my L will give me what? 2 multiplied by W over what? I squared, right? So that will give me 2 multiplied by, what is my W? 80 divided by, what is my current? My current is 2, that's 2 times 2. So this cancels this, and this here one, I have 40. So it means that the inductance is what? 40 Henry. 40 Henry. And that is the answer. Remember, the deal is that you must be happy, I must be happy, we must be happy. So do so well to subscribe, comment, like, and share. Thank you very much.